This question is on time, speed and distance. Pause the video for a minute and try solving the question. A train is running at a speed of 60 kilometers per hour, crosses the pole in 9 seconds. What is the length of the train? So the distance, which is nothing but the length which we require, is nothing but the speed into the time taken to travel. The speed is in 60 kilometers per hour, so all we need to do is convert it into meters per second, because the answer is in meters and the other time is in terms of seconds. So 60 divided by 3.6 will give us that into 9. This would give us the answer. So basically that is, the remaining part is only calculation. 60 by 0.4 is nothing but 600 by 4, which is 150. This is our answer. Now let's try and break down the concept and understand what all we need to be geared up with to solve this question. So basically it is a question in terms of, it's a standard scenario question, that is trains crossing poles or platforms. So a train would have a length of its own, and if it has to cross a pole, what is the distance it has to travel? So let's extend the pole. The crossover starts happening only when the train aligns with the pole. Then it continues till the entire train is traversed through the entire pole and the fag end of the train is aligned with the pole. So the distance which has traveled from here to this is nothing but the length of the train itself. So for a train to cross over pole, it's only the crossover. For a train to cross over the pole, the distance it has to travel is exactly the length of the train. That is what this question is all about. Now, there are two kinds of questions in this: a train crossing a pole, a train crossing a platform, or a train crossing another train. So these are the three scenarios what you can look at in these kind of questions. So as we understood the pole and the train concept, let's try and understand what happens when a train has to cross a platform. When it is trying to cross a platform, it's a similar situation. We have length of the train. Now let's say we have a platform. This is length of the platform. Now the crossover happens only when this is aligned. When the train is here, there is no crossover. So let's say if this is the direction of the train has to pass over through this. It goes like this. It goes further ahead till it completely crosses over the platform. That means the train should have traveled from here to here, which is the length of the platform. Now for the train to be completely out of the platform, it has to travel the length of the train itself. So when a train crosses a platform, that means it has to cross the length of the train plus the length of the platform. If it is two trains, it has to cross the length of the train 1 and it has to cross the length of the train 2. If it has to cross a pole, it's nothing but the length of the train. This is the basic concept for understanding what is the distance to be traveled by a train to cross over either a point or element which has a length of its own, which in this case is either a platform or another train. Anything otherwise, which is a pole or a gate, or if it says a stone, all these are points. So those will come under these scenarios. This basic is what we need to understand to solve these kind of questions. Let's try and solve this question now. A train running at a speed of 60 kilometers per hour is crossing a pole in 9 seconds. What is the length of the train? All your answers are in meters. The time is in seconds, but this is in a different unit, which is kilometers per hour. So the first step would be conversion of kilometers per hour into meters per second. You can use different methods. You can use the basic conversion of each of these into the respective units here. That is 60 kilometers. If I want to convert, each kilometer is 1000 meters. Divided by 1 hour is nothing but 3600, which will give us the solution. In this case, it's not exactly divisible. You will end up getting 600 by 36, which is nothing but 100 by 6. You can retain it. so that you can simplify to the next calculation level. Now, as we proceed, we know sometimes people remember factors. For kilometers per hour to meters per second, we have to multiply by 5 by 18. That is nothing but this. So you're remembering that. So it becomes a process every time, you don't have to do this. When you go in the reverse direction, when you have to convert from meters per second to kilometers per hour, it's nothing but 18 by 5. What I tend to do is, I know that 36 kilometers per hour is 10 meters per second. So I tend to use this as a reference and scale it up or scale it down. You will tend to observe most questions coming as speeds being multiples of 36. You will see 36, you will see 72, 108. In such scenarios, it's very easy to convert it. This is 10, this is 20, this is 30. You might even see 54. You should quickly know 54 also can be written as a multiple of 36, the same factor. You can multiply it with 10 meters per second and get the answer. These are different ways of conversion of the units. Now let's get to the solution of the problem. Now let's look at the solution to this problem. Once you have converted the 60 kilometers per hour into meters per second, we had got 100 by 6. It becomes a straightforward solution because the train has to travel its own length to cross over the pole. So the length required is nothing but speed into time, which is 100 by 6 into 9, which gives us 150 meters. That is the answer to this question.